In this video, we'll see how we can design a text-to-SQL agent. So the problem statement would be that a user will ask questions in natural language and we have to create SQL queries against it and get the correct data. So it seems a bit of a easy problem where you could just ask any of the agents that we have or any of the LLMs that we have a question that you need, and then it will create a query and then it will give us an answer. But there are other challenges that we need to highlight is that how does it know the columns it exists. There might be a lot of tables in your database. So all of these questions challenges we need to keep in mind before we design a system like this or an agent like this, right? So that's what we'll do. And if you've seen my previous video, we'll follow the same pattern, right? So we know the problem statement. Now let's think about what this actually does. So we'll have goals here, right? So in goals, what this particular design should do is it should create and run complex SQL queries. Okay, so it should create SQL queries which are all complex as well, right? We can add a metric that it should be 90% accurate, or the execution accuracy is 90 more than 90%, right? So this gives us a purpose on how we would design and make sure our system is going above this, right? Once that is done, the that would be the first step, first point of our design. Second would be how would we know how many tables we have, let's say. So basically we need to know the schema, right? So understand the table schema for, let's say, 2000 tables, a pretty enterprise level number, right? Third one would be we should have the capability to understand that whatever the user is asking, it should map to a column, at least to a column, and so that the query that it creates is error prone, or it can do the mapping of context with meaning, right? So something like rev is nothing but revenue, right? If I say amount is nothing but amount, right? So the user can type amount, but the column ID is like this. It could be anything, and they might write customer space ID, but then that matches to cust ID, something like this, right? So this type of understanding also we need to do. That could be something called as metadata linking, right? So it could be a dictionary a dictionary of all this mapping, right? Of, again, 2000 tables. This is very similar to table schema, but table schema we can also add stuff like what the purpose of that column is. So we have something like util underscore 345 underscore id. So what is this util? Is it a foreign key? Is it what is it a primary key or whatever? So sometimes it happens, so we need to add that also in this particular point. But the third is purely linking, okay, and the mapping. So this is what we can have. What else can we add? So if you ask a question, do you want it to generate a query and give you the data directly, or if you ask a query and then it gives you a wrong data? Rather than having that, we could say that the system should ask clarifying questions if the input is ambiguous, right? So that would make it better. I spelled it wrong. Yeah. So that could be one of the goals. It should ask clarifying questions. So if it's vague, ambiguous, we don't know how to do, so it will ask the user again. We need to make sure that it has zero hallucination. That is a goal. Whether it happens or not, that depends on our system. So the reason is it should not query a table that doesn't exist. And so we don't want this to happen, correct? What else can we add? If it's a complex query, we don't want it to take like 1 second and give us a wrong query. It's fine if it takes some time, right? So the inference latency is something we need to keep in mind, right? So it could be, that would depend on the type of query. So if it is simple or complex queries, we could have maybe less than 10 seconds for both, right? I think that should be pretty much a good latency for, if you ask a very complex query and it takes 10 seconds, I think I would be happy to wait for 10 seconds, maybe less than 10 seconds, but it should give me a correct query and the data should be correct. And one more thing would be caching. So we could do caching, which is also called as semantic caching of queries, right, or data as well, whatever we pass through. This would be an entirely different way of solving this particular problem, right? Apart from this, so we just mentioned it. It's better to have it. Okay, so these are the goals that we should have for our design. Then next step would be scope. What are we trying to implement now? So we'll say it should create queries similar to previous if it is there, you know, so that it utilizes the cache if it is, or something queries that are already in your system, and then you ask a question which is very similar to that, a bit of modification, and then you can it can easily create that query, right, which falls into the one shot technique, prompting technique. Then schema understanding, and we could do this with RAG. So we have a agent that goes to the schema and checks the similarity based on the question asked and does the mapping and everything. So that would be the second point. Then context linking, which we discussed earlier. So understanding the nuances of a value in a column. So something that is having, so databases tables having high cardinality. I think it is worth noting that, right? Then we need to check whether the query is correct or not, right? So the correctness of a query. And the last thing could be an correction loop or a feedback loop. So if the query for wrong queries, right? So it can go back and analyze the error and then solve it, modify it, and give you the correct query again. Right. So this is the scope, which is I think good enough. Then we could also do the last thing that we discussed even in the last video is guardrails. This is very important, right? So we never generate, or we can generate, but let's have that for this design, generate or execute queries that have delete, drop, update without human intervention, right? This makes it safe so that we don't do something crazy and delete everything, delete rows and stuff like that, so that doesn't happen. And I think it's very fair that we don't generate it also, right? If some, what if the human misses as well, that would be a higher cost to pay. That one. Then the token cost, we don't want to go with respect to context length, because if it's going above a certain level, then you can have some percentage here. Okay, I'll not put that right now there because you need to have a justification for that, and there are multiple ways to justify that. So a bit of, you can just read about it and come up with a number. Okay, and the thing would be the loop. So we talked about the correction loop. So limit the number of iterations that we do. We don't want it to go for like 10 different iterations and still give us wrong queries, right? So you can do this at the design level where it starts, gives the query, and you can also do it at the node level where the query itself is wrong, right? All this stuff you can add it, right? One important rule that we need to add is about the database admin, the security that we add to the users, to the one who actually execute it, and the way we create automation scripts and that accesses that we give it to the table and database. So something like row level security we can add, right? So and accesses are based on who is asking, right? So that is something we should keep in mind. And I'll add one last thing would be privacy. So info is not leaked or it should be masked, something like that. That would be there, right? So these are the guardrail scope goals for a system where you want to design a text to SQL agent. Okay, so now let's get into the designing. Okay, the first thing that we have is, let's create a block which says user query. Okay, so the user is going to ask a query, and I think we did mention about semantic caching, right? So it is safe to say that we could just have a block, something like this, which is a semantic cache, and whenever a user query comes in, we just check whether it exists in the cache or not, right? So we do something like this, and we check if something is there. We return back to the user. But it's important to know that if it's not there, what do we do, right? So let's say it does not exist. So we should have a system now that actually starts the flow where it goes to the semantic cache. It's not there. What do we do next? We check whether the query is ambiguous or not. That's what we discussed, right? So is the query ambiguous? That's what we'll check. And if it is, now this condition, if it is, we said that we have simple and complex query, right? If the query is ambiguous, we need to make sure that we ask a clarifying question, right? So this goes back to ask clarifying. So we ask clarifying questions. So from here we go here, we say yes, the query is ambiguous, and then we go back to the user. Okay, and yeah, so so it goes to the semantic cache, and we see, hey, it's a miss. We have There's nothing something like this in the system yet, right? So it's a miss. So if it's a miss, we go to the we answer the try to answer the question, is the query ambiguous? It was yes. We ask clarifying question, go back to the user. Okay, that's how the loop is, the first loop is. But what if our query is not ambiguous? Now we go to the actual flow of our system, right? So if you have something like this, let me make this, I don't know, let's something like this, right? So our query is not ambiguous. What do we do? So we discussed that we should have a schema understanding, create queries, have context linking, understand the table schema, right? So that's the first thing that we need to do. So if I say this could be something called as context retriever, I think that should be good, something like this, right? So a context retriever where our main job is to understand what all things are needed here, right? And the first thing would be getting all the table schema. But if you get that, do you think if the 2000 tables, should we get all the 2000 tables? No, right? So ideally it should be find the top 5 to 10 tables which are related to that. That is the main purpose of this particular node, which is the context retriever node, right? So the 5 or 10 tables are important. We can have the mapping metadata in this node as well, context, which again basically means if someone is talking about Apple, it should know that in this context is going to be maybe a column name, right? Something like this, company name. whatever there is in your schema, and then all of this we do by performing rag. So if you want to do rag, I think we'll need a database for that. So we can have a vector db. We have many different vector dbs like quadrant, VV8, and stuff like that. So you can have this database over here, which is your storing all the table schema in format that works best in this scenario, right? So you have your vector DB here, and your task would be to generate to do rag and get the top 5 or 10 tables from this with the schema. Right? So this is the first node that we visit after this particular loop. Then we got all the top 10 tables and everything. Now is the part where we need to perform a query or generate a query, right? So we'll have one more node. Let's do it over here. And so what we can do is have this as a SQL node. This could be an agent also. So we have an SQL agent here. Right. And what this is going to do is this is helping us once we get everything combine all of these stuff, right? So we got the schema, the table, info. So if anything is there, the rules that we have said, everything comes over here from this particular node, right? So this comes over here, and we start getting that, and this is what is used. And we also put the one shot or few shot techniques here, so that if something is there isn't much change for the question and we have already written those queries, this helps us generate it in a very faster way. And we could also add the reasoning and a chain of thought. How did you come to this conclusion, or how did you come to this particular understanding of my initial query? This is what we could have in this particular node, right? And so I'm writing it in one complete node, but I think if you want to show it in an interview, you can create one node here, then you can also create one node over here. This would be your uh, chain of thought, and this is going to be your the first 2 points that we discussed right now, right? And then you could have an arrow between this, right? So that is something you can do if you want to explain it in a better way if you're in an interview, right? In your interviews. But right now I'll just keep it very simple so that it's easy. Once that is done, we got all this information, we are going to generate our query. And once we generate our query, we'll have other problems with it, right? So let's say we come over here. This is another node. What we're doing is from this particular part, we generated a query, and we're going to put, I'll tell you what you're going to have over there. So you generate an SQL query. We have not executed anything, right? Before we execute anything, what do we need, right? So let's copy this, put it over here, and say this is for guardrails and validation of the query, right? So is the query syntactically correct, right? So that is very important. Let me create a node within this node. So we could have a syntax parser that does our thing that we have that we want. And what this will do is we have it over here. So it is going to check whether it is a safe query or an unsafe query, right? So if it's a safe query, we can just add this part. Let's say do something like this, pass one arrow here and say, hey, it's a safe query. I think in the sense that it is correct query. And then we go to the row level security to check who is asking, right? That is also important thing. If someone unauthorized is asking, we shouldn't do it, right? Here it goes to the unsafe part. It can go to the error as well, and give a reason to the user. So that's the unsafe that's the safe transition, right? And if everything goes correct, what we are going to do is we are going to execute the query, right? So we'll have a block over here, something like this, and we'll say execute. We execute the query, which is coming from this particular block over here, right? So if you execute the query, it will go inside the database. So I have it here, so let's do this. So it will actually go to the database and get you information that you need. So this is the actual DB based on the question that was asked, or the table that it had to go to. All of that stuff is over here. Okay. So from here it comes over here. What is going to happen at this stage is there are two things going to happen over here, whether we got the information or not, and then whether we got the information or not, right? So we are right now looking at the happy path. We got all the information, generate a query, went to the parser. It is a safe query. The access is given. We execute the query and we get the, you go to the database, and now that also happens in the most amazingly correct way. And we come over here, we should have a response node, right? So if you get all the data which is correct, how do you want the response to be? Is the response based on text, respond with text, or a table, or anything, right? So anything that you want, you can have all that instructions tuned over here, so that the node goes, so that the response to the user is in this way, right? So this is the happy path where like we execute the query, it comes and goes to the response node, in the sense that this was a success, right? No errors, happy path. And if you get that, what you're going to do is, you are going, if you remember, we have a cache over here. So we'll go from this particular node to our, add it to the cache, and then it goes to back to the user, right? So that's the happy path we did. Now let's look at the unhappy path. So if it's an unsafe query, what should happen, right? So we could have another node over here, which is just the error fixer or parser. You could have this over here. So things like, this is not syntax error, this is the context error, like column name, like we mentioned at the start of the video, was amount, but it created a query empty, something like that. So something like this happened, and then it did not give a response. It actually generated an error, right? So we need to fix this error. So we could have that over in this section, in this particular node. That happens with the in, with when we execute the query, right? So it is from this particular understanding, right? So database SQL error, and that happened, right? This is just one node, but you can customize this as you want. Also, from this part, I think it is important that if it is an unsafe query, it should come here and fix it, where we have the guardrails here that would tell you at this particular node, the internal node of this particular node, what to do, right? You can customize that, but it is worth mentioning that you could do something like this as well, right? If that happens, what do? You are stuck here at an error. So we need the feedback loop, which we have discussed before. So where does the feedback loop come from? It will come from here, but go where? It goes from here back to our node, right? So this is the feedback where we send it back and check what is wrong, right? It will tell us that, hey, the name was different, so the table info is updated, and that's how it goes. So we could add the number of iterations, limits, all of these things in this particular loop. Okay, so that's how we got the feedback loop, and we also added the success. So pretty much looks like we have come up with a good system that is able to have one complete flow. And if you think about it, this particular entire section, right, is nothing but the processing, right? So this is like input, processing, right? So this particular few nodes are the input processing of the entire flow. Then when you go down, this becomes your, let me make this smaller, this small section becomes not this. I think you could add the entire thing, right? So this particular things becomes the design of your system, right? Where you are doing all the things like context SQL flow maybe, right? So this particular section becomes that, and in the end we actually have the the actual database interaction, right? So it's, I think it's better to add that also. So something like this. So this is your actual database interaction to get the information, right? So I think this pretty much sums up the nodes that you have created to create this particular text to SQL agent. And come back here, I think, yeah. So I think this particular approach gives you a pretty much high level flow that how you should design your text to SQL agent. And if you use LangGraph, I think this would be all your nodes, and then you would create these graphs and connections in that. So yes, so this is there. You can add the time limits over here that we discussed. There could be a small section that is calculating the token cost. All of this can be added at every stage. So when I mentioned that the iterations at design level and node level, you can add the token cost at this particular node, this particular entire set of nodes, and then calculate and have that guardrails and rules in place. So that's how you could design a system. One of the ways to design a system. There are many different ways that you could do it. So I hope you learned something in this video. If there are any questions, something that is wrong, please be open and comment below so we can fix it. Awesome. Thank you.